Okay, here's our first example. This is sketching, remember? So you have to remember your transformations. Remember there are several transformations on the graph of a function. There's the shifts up, down, left, right. There's reflections through the x-axis. And there's also vertical stretches and shrinks. So here's our first example. Sketch 2 to the x plus 3. Okay, first of all, remember when we went over the 4 steps in the graphing a function. Number 1, identify the basic shape. Well, this part right here, 2 to the x power, x is in the x power, that is the exponent function. So remember from before, the basic shape should look like that, you know, with a asymptote line. Okay, and it normally goes through 0, 1. But this part right here, if you're watching, you probably know this is a shift in what direction? It's shift up 3 units. The whole graph is shifted up 3 units. But what are we using as our reference point? Remember, all the other functions go through 0, 0. This one goes through here, 0, 1. But everything is going to be shifted up, even the asymptote line. So instead of 0, 1, it's now up 3 units. So this is a shift up 3 units. So this point right here is going to go 1, 2, 3. So it's now going to be there. Now the asymptote line is also shifted up. It used to be at the x-axis. Now it's 1, 2, 3 up. So it is now here at 0, 3. Yep. And then it's not vertically stretched or what do you call it? The opposite of stretched, shrunk. It's just shifted up, so the shape is still normal, so it's still like that. Remember, this is not like a parabola. It doesn't go down and come back up. It's curved like this. That over here on the left side is just going to keep going on and on towards this red asymptote line. Okay, so this is shifted up. Got it? Okay. Now let's do some other equations, but without drawing. You'll see this on Math Excel. Blank. Yes, I want to blank. It's lagged. Okay. Uh-oh. It froze. Yes. Okay. So, describe the graph of f of x equals negative 2 to the x plus 1. Okay. Well, there are actually 2 transformations. Can you see here? There's one there, and there's one there. But it's still the basic shape is the exponent function. So describe the graph. So this is the exponent function, first of all. So we know the shape. It's like that with the asymptote line. Da 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 da. Then this negative in front of the whole function is actually a reflection. Or we'll call it reflected through the x-axis. Now, the plus 1, do you remember, is a shift what direction? Left 1 unit. So these are some things that you need to do. If we graph this, this would be reflected. Actually, I'm going to show you on my next video what reflected looks like, but you should know at least these transformations in words. Okay? Okay. In this video, I'm going to talk about reflected graph. So this is the normal 2 to the x exponential function. If you see negative 2 to the x, that means the whole function is negative. It's reflected through the x-axis. So the x-axis, remember, is right there. So just everything is a mirror image. So instead of 0, 1, it's 0, negative 1. And then you draw it as symmetric as you can, as if there was a mirror or there was a water line right there. So this right here is the reflected version of the regular one. Oh gosh, so messy. There you go. Okay, so this is what reflected looks like. Now, there's something else about the exponent graph that you should know. I'm going to do a blank piece of paper here. The normal graph, like that, that's the normal is increasing. You can see from left to right, it's going up. But there is such a thing called a decreasing graph, decreasing exponential. Maybe I'll use green. It looks like that. Hope you can see that. It also goes through 0, 1. Now, if you see either of these two, the base is bigger, smaller than 2. In fact, if it's smaller than 1, between 0 and 1, like 1/2 to the x power, or if the exponent is negative, this means this graph is decreasing. This is not the same as reflected. Decreasing looks like this. It's going, and it's still asymptotic over here. Okay? So that only happens when the base is a number between 0 and 1, like 1/2, 1/4, 0.25, anything smaller than 1, or if the exponent is negative. If the exponent is negative, it shows a decreasing graph. Remember, that's different from reflected. Reflective is if the negative was down here. Okay? So there's two types of exponential functions. An increasing, which is normal, the base is bigger than 1, or decreasing, the base is between 0 and 1, or the exponent is negative.